Welcome back to Lesson 12, Connections Part 5 of the SDS2 Getting Started series, where we will continue with moment connections. Let's begin by setting this back to a clip angle connection. And remove that tension load. Let's look at some of the required fields in setup for moments. I'll begin by tearing off the job option setup portion of the project, and we'll go down and start with design criteria. Now first off, you'll see we have the base beam design moment on percent of maximum allowable moment. By default we have 85%. Now, it's important to understand this. The engineer usually indicates 100% moment, which is fine when you're dealing with a welded moment condition. SDS2 is going to work just fine for this. But if you put 100% in here and you have a bolted moment, the question is that 100% of the gross or net area on that particular top and bottom flange for this moment? So this is something that needs to be calculated. Best case scenario is the engineer actually gives you the particular moment that's required for your design. Over here on the left hand side, seeing that we're dealing with the loads, by default SDS2 uses kip inch. Most engineers indicate on their drawing kip foot. This has caused a lot of problems for people if they don't understand the difference between kip inch and kip foot. So if you want, if the engineer says that he's using a kip foot, go ahead and change that so you can put in the exact kip foot value that they request. I'm going to leave mine at kip inch. Design moment connections for greater than 100%. What happens here is that this is when you have a welded or an end plate moment to a column flange only. What the system will do is it will design up to 125% for the column. Seismic, we're going to deal with this one a little bit further on down the road when we look into our setup. Next, you can go and refine your plates right here for your thicknesses, available thicknesses. I'm going to look at moment flange plate, and you can set the grade for those moment flange plates when we're dealing with a bolted moment condition, which we are currently not going to be looking at. Finish on this screen with flange force load factor for moment connection to column flange. That will only apply if you're using the ASD 9th edition. Next, let's move on to the weld design criteria. We can see here that we have, for example, moment connections, the gap that's used, the reentrant cut radius. We're going to talk about the reentrant cut in a minute. Root face dimension, web setback, groove angle, and alternate 1 reentrant cut radiuses. I would like to mention down here we have the reentrant cut. You can see we have alternate 3 and alternate 1. Let's go ahead and discuss this for a moment. No pun intended. Okay. In the AISC manual, on page 16.1-328, you'll see that there's an alternate 1, alternate 2, and alternate 3 type of rat hole or reentrant cut radius holes that are available to you. Now, if we look at it, SDS2 only provides alternate 1 and alternate 3. Now, a lot of times people mistakenly called the alternate 1 a FEMA cut. If you look closely at that particular picture, you'll see that alternate 3 is only for built-up shapes. Unfortunately, this is one that is typically used by a lot of fabricators, even though it's only really available for built-up shapes. So we have defaulted to alternate 1. We'll see what this looks like a little bit further when we get into the model. Now, the third type of reentrant cut that we provide in SDS2, because we do not provide the alternate 2 type, is the seismic. Now, if I go back into my design criteria, you see that there's an option here for seismic moment connections. If you select the switch here or on the member edit screen, SDS2 is going to use the seismic connection access holes that we can see right here in this particular table, and this refers to the seismic access holes that are in AISC manual for seismic design on pages 118 to 125. and these are tables 1.1 to table 1.8. In short, what happens in the material file in SDS2 for each section size, you'll see that there's a seismic access hole, which reads its values for the access hole from this table right here, which is in the job setup seismic weld access hole configuration. So whenever that section is used, the seismic access hole will be provided. Now on to the moment plate design criteria. Here is where you're going to set more information about the configuration dealing with primarily the stiffeners. We can see that there's an option to column flange and an option to column web. Right now we currently have to the column flange. For the flange stiffeners, it is set to as needed. The same setting for that stiffener or continuity plate for the plate thickness is design as needed as well. I'm now going to edit this member and set it to a moment. Start by going to this moment tab up top. Let's come down and start off with a welded moment. Again, as mentioned earlier, whenever you see something that says automatic, that means that the system in setup has the value. That's where it's going to read it from. Let's go ahead and hit OK. It's going to ask if I want to change all the members. I'm just going to change this one. And let's run this through process and look at our results. Now what we see here is that this particular moment caused the column to have continuity plates. So when the system is designing this, we're not just checking that beam, we're also checking the column to see if it can handle this moment. In this case, it cannot handle that moment. Now, because there's continuity plates, you can no longer lower this beam down the web. So therefore, the system automatically changes this to an extend past flange shear plate connection. Now let's take a closer look here at these reentrant cuts. Now right now, this is going to be using the alternate 1 type cut. Let's go in and edit this member and change this cut right here using the reentrant cut alternate 3. Run back through process. And that's the cut that I talked about earlier that according to the manual is supposed to be used for welded wide flange sections. Now what about the seismic? Let's go back here and change this to the previous alternate 1 type. So we can go ahead and get a visual here. And now to get that seismic cut, you must change this to a seismic connection. So seismic moment connection, I'm going to go ahead and change this to yes. Of course I can change it in setup and then mark things for process because it was a setup change. See the difference between these different cuts. So the system reads from the material file what cut it's supposed to use and then goes and provides that particular cut. Now for a few more options. Let's come in here and rotate this a little bit to look at this connection. We can see currently that there's a doubler on both sides of this particular column. Now in setup you can tell the system which side you always want to use, but on the member edit screen we can change that rule. As I come down here, you're going to see column web doubler side. I'm going to change this here to a far side. Of course, has to go back through process. And now we basically have a doubler on only the far side of this particular column. So the system is again checking that panel zone crippling point within that column. Let's go into our setup and deal with the stiffeners. Before we go into the stiffeners, let's go and change this moment to 6 kips. As we can see, the indication kip per inch, and negative and positive does have an effect on here. So if the engineer indicated a negative, input a negative. Let's go and change this to a really low 6 kips, which means that when I process, the system will go ahead and there are no continuity plates required. Again, the system went back and set that to a clip angle connection in the web again. Okay, so we know at 6 kips that there are no stiffeners required. When I come back in here and change this from 6 kips to, let's go ahead and just set it back to auto. As we saw earlier, the stiffeners are required. Now, I'm going to go back in here and I'm going to change this to 6 kips again. And in my setup, in the moment plate design criteria, I'm going to tell the system to use full depth stiffeners at all connections. Now, if I make a setup change, I usually have to go in and mark everything for process. But in this case, by editing the member before, the member is already flagged to be processed. Now we can tell, even though the system says I only need 0 stiffeners in here, because I told the system to always put full depth stiffeners, the system will always put full depth stiffeners. Okay, let's go back into the moment plate design criteria. This time I'm going to say, when needed, use a full depth stiffener. While we're at it, let's go ahead and put a cope on those plates instead of having a clip up here on top. Notice that the system did not flag that member for process. I'm going to go ahead and I always mark the entire node for process. This way we can be sure we're going to get the accurate results. Now you'll notice the system did not provide a stiffener. Let's go in here and raise this back to that auto load. And now the system does require a stiffener, and we can see that there is a stiffener here. Notice that we also have that cope that's been added in here. Okay, let's rotate this back around position, and I'm going to modify my depth check on this. Let's go ahead and set this out to be 3 feet. Just because I can see a little bit more material. Now to complete connections, I'm going to talk about a little feature in the member edit screen called Redesign. When I come in here and I edit this particular member, and I go down, and you'll notice at top here on the left end, which is where we're concerned, where we're looking at, it has the shear tab being used. If I go ahead and hit Redesign, we'll see that the system is going to come back and say, oh, here's that original near side, far side clip. Let me explain what happens here. Whenever you hit Redesign, it will only look at the 2 connecting elements. In process, we go through this framing situation. Redesign only designs between those 2 elements. So if I go ahead and hit Redesign, it looks like I'm going to be getting a clip angle. I run this back through my process and create solids, and I end up with a shear tab. Again, the reason is process and create solids goes through framing situation, looking at the connectivity of this entire node. So what happens if I go and hit Redesign, which develops that clip angle connection here, and then set it to user? Now user, as I mentioned earlier, locks the connection. Well, at least the majority of the time. There's a few particular situations where it may pop out. Now I'm going to go ahead and hit OK, and I'm just going to mark this entire node to go through process, and we can see that the system has gone through and let's go ahead and set this to be 2 inches out, and it has created that clip angle, because when it went through framing situation, it said, hey, this is user, this is locked. Now remember, when it's in user, you're in control. So therefore the system didn't recognize that continuity plate that's here. So since I'm in control, I'm going to come into this particular connection, go into my end prep, and let's go ahead and add in a clip or a cope or a block or however you want to call it. 4.5, 1.5. Run this back through process. And we now see that we have, let's go and set this out to make it a little easier for us to see this nice 3D node connection going on here. So here's an example of using the user option. There is another option instead of user, which is called the lock option, which will be discussed in training class. This will conclude for the moment the Connections Lesson 12.